Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn about C# records. This is a super simple way to create immutable types to organize your data. Okay, so records. The basic usage is actually incredibly simple. So first you write the access modifier, like let's say public, then we write the record keyword, and then some kind of name for this type, like let's say person, and then we open the parentheses, and we write our parameters. So for example, something like first name and last name. And yep, that's it. Just with this, we have created our person record. So as you can see, if you need to organize some data, it can be similar to just define a simple record as opposed to defining a whole class. So for example, something like this, so person class. If we had this, we would then have two properties. So one for the first name with a get and a init, meaning needs to be initialized, and same thing for the last name. So yep, basically over here, we have the exact same thing written twice. We have two pieces of data, which in the case of records, the underlying compiler, these are actually auto-implemented properties, and they are also immutable, meaning they only have a get and have no set, and also they need to be initialized. So yep, this super simple record is exactly the same thing as this. You can see how this is quite a bit easier to write whenever you need some kind of structure to hold some data. And then to construct a brand new person, you really just find person, and then you can do new person, or really just open up the new like this, and then pass in all the parameters. So in this case, let's say CodeMonkey. And if that's it, here is our brand new person. So we easily defined in just one line of code and easily created in this one. Then with this, let's do a console.writeLine in order to see person, what this says. And if there it is, the toString automatically writes out the actual type, so person, and then all of the parameters and all data they have. So yep, this is how simple records are. And now by default, records are indeed like this, meaning they are immutable, they have no set, they cannot change. Here, if we try creating a brand new person and then go inside the first name and modify it to something else, nope, this does not work. This one can only be set once it is initialized. It cannot be modified afterwards. However, if you really need to, technically you can make it mutable. You just need to define the record, and then instead of doing a semicolon, you just open a code block. And now inside you can define all the properties. So for example, first name. And on this one, let's put it with a get and with a set in order to make it mutable. And we just have to do equals first name, in order to make sure that the value that it receives over here is the same one that is set to this property. Simple like this, if we now do a person and go inside person and modify the first name to something else, yep, now this is indeed valid code. However, records really are primarily meant to handle immutable data, so you really should avoid doing this unless absolutely necessary. The fact that they are immutable is indeed part of the purpose. Immutability is really great for handling static data, especially when working with things like multi-threaded code. If you have multiple threads, all of them accessing an object that is mutable, it can cause all kinds of strange issues, all kinds of race conditions when multiple threads try to write to the same field at the same time. Whereas if a field is marked as immutable, meaning that data can only be read, that eliminates all those issues. Now if you want, you can also do something that is called non-destructive mutation, which really just means creating a brand new record based off another record. So for example, over here we can do person, call it person2, and we can start from data contained inside person, and then use the keyword with, then open some curly brackets, and now here overwrite any of these. So for example, let's say last name, set it to Gorilla. And yep, just like this, so now we have person and we have person2. And yep, there it is, the first one CodeMonkey, second one CodeGorilla. Now this is technically called non-destructive mutation because in reality, it doesn't really mutate the original data. This one still stores the exact same thing, basically just creates a brand new one using the parameters from the previous one. Also, over here, we are really just using the record keyword. But what this is really doing is really the same thing as writing record class. So by default, records are going to be classes. However, if you want, you can also make it a record struct. Yep, this also works. So your records can be either classes or structs. However, in terms of equality, they mostly behave like structs. They mostly behave like value types. Meaning if we make this a record class, and up here, let's create two persons. So let's call it and person3. So here we're doing new twice, so technically these are two objects. So if person was a class, these two would be different because they are different objects. However, if we do a console.writeLine, if we do that and we check person equals person3, if we check this, yep, this one does return true. Now in a normal class, if this were a normal class, this would return false because these two are technically separate objects. However, since this is a record class, because that, the equality behaves more like struct, meaning it checks the underlying values for the equality. Again, this is because records are really primarily meant to be used for data organization, so the equality logic is all made based on that. Then if you want, you can also handle inheritance with records. So for example, we can do a public record, let's call it unit, and inside let's do some kind of float for some kind of speed, and then we can have a public record for some kind of player, This one receives a string for a player name and also a float for a speed. And this one then extends unit, and for the parameter, it passes in the same speed parameter. Yep, that's it. This is valid code. Also, one more note. Technically, records were only introduced in C# 10, and Unity is actually currently on C# 9. However, it does support records, but in order to make it work, it requires a slight workaround. So here I have some Unity code, and if I define, let's say, some kind of record for a player, receives a string for the player name. So this is a record. However, if we do, we see this error. So predefined type system.runtime.compilerservices.isExternalInit is not defined or imported. So in order to make this work, in order to make records work inside of Unity, for that we basically need to create this type. So we need to put it inside of this namespace. So we need to create a class inside of a namespace. So let's do a namespace and name it like this, exactly like this. So system.runtime.compilerservices. Let's open and close. And then inside we need to define a class. And the class has to have this exact name. So isExternalInit. And define a class just like this. So it's all completely empty. It really just needs to exist. And if it does exist, then yep, this is now valid code. Alright, so records are an interesting way to very quickly define a type to hold some data. Instead of defining an entire class or a struct, you can very quickly define a record and have it with the perfect accessibility for some immutable data.